Small cars get better gas mileage, but they are not as safe as bigger cars. Small cars accounted for 18% of the vehicles on the road, but accidents involving small cars led to 11,898 fatalities during a recent year. Assume the probability a small car is involved in an accident is 0.18. So we know probability of a small car accident is 0.18. The probability of an accident involving a small car leading to a fatality is 0.128. So we know probability given that it was a small car that was in an accident, probability of fatality is 0.128. And the probability of an accident not involving a small car, the probability given that it was not a small car, leading to a fatality is 0.05. So fatal accident given not small car was in the accident is 0.05. Suppose you learn of an accident involving a fatality. What is the probability a small car was involved? So probability that a small car was involved given that there was fatality is equal to what? That's what we're looking for. We know from our formulas that probability of S and F, joint probability of S and F divided by probability of F gives us that answer. But we can use our, again, tree branching to solve this problem instead of the strict application of the formulas. We know that since we have probability, the simple or marginal or prior probability of a small accident being small car being in an accident is given to us, we'll start our analysis with probability of S, which is 0.18. So this will be probability of not a small car being in an accident, which would be the 0.82, which is a complement. Now here on this these branches, second set, we're going to put the conditional probabilities of fatality given small car and probability of no fatality given small car, because this is the condition that leads to those two branches right here. So here we're going to also put fatality, not fatality, but now the given event here is not a small car. So those are what we will put there. And now we are ready to put our probabilities under. We were told F given S is 0.128. So the balance of it of 1 is 0.872. Oops, put it on the wrong side. 0.872. 0.872. And then we also know probability of fatality given not a small car was 0.05, so the balance of it would be 0.95. Let's put our joint or intersection of events here. This would be probability of F and S. The way you can do that is by looking at the two events that are in the conditional probability. Here we have events of F and S, and so you will put F intersect S. All right, then we have probability of F bar and S, probability of F and S bar, and probability of F bar and S bar. And these we know we can compute by multiplying the probability, the prior probability times the posterior probability. So 0.18 times 0.128 is 0.023. The next one is 0.157. The next one is 0.041. And the next one is 0.779. At this point, we're ready to answer this question. And the reason is that we know the two probabilities the two joint probabilities that contain the event of small car being I'm sorry, the fatal car being in an acc a fatality occurring uh, is given by this and by this. This is fatal and the car was small. This is fatal and the car was not small. So we have these two probabilities. If we add them up, we get this probability right here, which is 0.06. I'm sorry. Um, that this is probability of F and S, and this is probability of F and S bar. So those two give us this probability right here, probability of fatality, and that is 0.064. The joint probability of F and S, or the intersection of the two, is 0.023, which goes up here. So at this point, we're ready to compute this answer, which is 0.359. So that's the answer, and I will color it yellow. That's the answer to our question, right there. But if you wanted to, you could answer that by tree flipping. So we start with the F probability of F and F bar, fatal and not fatal accidents. And those probabilities on the second branches would be probability of small car or not small car, probability of small car or probability of not small car. But these are all conditionals, and the condition here is F, so I will put them. And the condition here is F bar, so I will put them. Of course, we're looking for a probability of S given F, so this top branch right here will be my answer. But in order to do our computation, we need to first put the end values or the joint probabilities here. This one right here would be 0.023, which is probability of S and F, and we get that from up here. The next one will be 0.041, which is the probability of S bar and F, and I get that S bar and F, this one. The next one will be 0.157, and the bottom one, of course, would be 0.779. I will draw a line, a red line here, to separate these two trees so you can visually keep them separate. Okay, and these probabilities are probability of S and F bar, and this is probability of not small car and not fatality. Okay, so I know that these two probabilities end up being added up together, end up being the value that should go on that prior probability branch. So I can put that 0.023 plus 0.041 is 0.064, and of course I know that these branches right here, these two joint probabilities will have to add up to this marginal probability. So I can put that, which is 0.936, which of course these two, this branch and this branch, add up to 1. And now at this point, if I take any of these end values and divide them by the probability on the prior branch, I will get this answer right here, which 0.023 divided by 0.064, which is, remember what we did here, will give us 0.359, 0.359. And similarly, you can take any of these and divide them by the prior branch probability on them. And so I will just write those for you, 0.641 and 0.168 and 0.832. Of course, we know that all of these add up to 1, both of these add up to 1, and each set over here adds up to 1. So these two over here add up to 1, and these two over here add up to 1. All right, I hope you found this helpful. Thank you.